It's okay. I know some people take calc as a 0 3. All right, here we go. Not too many this time. On this page, kiddos, we're talking about all the pre-cal review stuff. Austin, you'll be listening to this hopefully sometime later. Sorry you couldn't make it. Exponential functions. Okay. Remember, exponential and logarithmic are inverses of each other, right? So where a log has a vertical asymptote. What? No idea. It's okay. You can go with it. Just roll with it. Asymptote. I know. Here's the word. Exponential functions. So we're all just digressing. Exponential functions have a horizontal asymptote. So Tyler brought that up, and that's very true. So logarithmic have a vertical. Exponential have a horizontal. We can talk pre-cal really quickly. Exponential functions that are non-transformed, whether it's an e or a b. B is just a constant, right? So like 2 to the x, 4 to the x, e to the x, 10 to the x, 12 to the x, right? The domain is always going to be all real numbers, because it's forever left, forever right, but what's the range?
It's zero or infinity.
0 to infinity, but not at 0, so y is greater than 0, true? So then if we were taking the limit to infinity of an exponential, what would that limit be? Yeah, good. As I go to the right, my function is going to positive infinity. How about as I go to the left?
0.
0, the horizontal asymptote. What is the derivative of e to the x? Let's review. It is calculus.
E to the
x. Okay. So if we know all of that stuff, and we know the derivative of ln is 1 over x, let's go ahead and look at this page. What if we wanted to find the derivative? We already know e to the x, so what about b to the x? Well, can we change the base of an exponential function from b to e? The answer is no. We can change the base of logarithms, but we can't change the base of exponentials. So if we can't change the base, we need to break apart the function. And the way to break apart a function, to break apart an exponential function, is to take ln. Because the property for logs say, oh, hey, if I have ln of somebody raised to a power, what can I do with that power?
Bring the x.
I can bring it down. Now, yesterday we kind of started to see something like this. I'm actually teaching you something from 2.5 to show you where this rule comes from. You're going to have to just kind of follow me on faith and be like, okay, we're going to get better at this after the test. If we wanted to find the derivative right now of y, we would have to take d dx. And what we do to one side, we have to do to the other. We know the objective was to take a derivative. I'm just going to show you how this works. I'm not teaching it to you. It shouldn't necessarily be in homework. We're just going to have a rule and memorize it, but I am showing you where the rule comes from. Is ln of y ln of x?
No.
So we think of it as ln of u. And how do I take the derivative of ln of u? When there's a log, we...
One times
Okay, so...
1 up.
1 over.
Yeah, 1 over.
Times y prime.
Y prime.
Which is dy dx. Or y prime. We could have written y prime. But you guys have heard me say I don't really like y prime because the apostrophe of the y is at a 1, is at a prime. Anyway, we could have written y prime. 1 over u times u prime. 1 over y times y prime. Or dy dx. Now, if we come over here on this side and take the derivative, okay, it's more normal. There are x's. There's b2, but whatever. If you want, you could think about it as product rule. It's not necessarily bad. When you do product rule, second d first, we would have ln of b times derivative of x is 1, right? Plus first d second. What's the derivative of ln of b? It's not ln of x, so b 1 over b times b prime. Wait, who is b?
He's just a
Constant. Is a constant.
0.
So exactly. So if b is a constant, when I go to do 1 over b times b prime, I just get 0. 1 over b times 0. I get a 0. So then all of that is just going to cancel out. That's just 0. And if I needed to solve for it, which I do, if I need to solve for dy dx, well, who do I need to move over? So dy dx is going to equal y times ln of b, and question, who is y? And who is that to begin with in this problem?
B to the X.
So we're going to go ahead and say, oh, hey, I know who y is. He was b to the x. So let's go ahead and plug it in.
Oh, okay. Oh.
Exactly. Just like we did yesterday, we talked about the log base b formula and said, hey, you can find it this way.
So
But technically, log base b of x is really similar to ln of x. They both have 1 over, right? They both think of 1 over the log. But an exponential, well, let's see how they're similar. Sean, did you have a question on this page?
I was just wondering, like,
Oh,
so you can use deriving as like an operation, kind of?
Can you explain that? Like what you see that made you think that?
The second step, using it as a way to.
What you do to one side, you can't do to another. Yeah. You have to still think of the legal algebraic rules, so we need to keep it balanced. So if we're taking the derivative of one whole statement, one whole equation, it's in essence of both sides. I would call it an operation, but the only legal way to take a derivative would be to follow the algebraic rules. Kiddos, you wrote this down already. So I want you to go ahead and check out e to the x and b to the x. Question, how similar are the exponentials, whether it's an e or a b? Super similar, right? Derivative of e to the x is e to the x. Derivative of b to the x is b to the x. But you need ln b. Wait. What was the derivative of logs? Derivative of ln of x was 1 over x. Derivative of log base b of x is 1 over x ln b. So both log base b and b to the x both need ln of b. Does that make sense? They both need that little extra piece. Now, there is a silly way of remembering b to the x, and just a quick hint, sometimes the rule might say a to the x, or c to the x, or a to the u, or c to the u. It's just a constant, so different, like the AP might call it an a one second and a b the next second, I might call it a b, then an a, the book might call it a b, then an a. But here's a silly way of remembering, okay? Derivative of boo is boo limbu. You're welcome. There was a kid, like 5 years ago, 6 years ago, who was like, I don't know, for some reason they just were like, boo, and I was like, all right, let's remember that. Or maybe I thought of it, I don't even remember. Then we were like little robots, and we were like, boo, and then, and it was, but the problem was, there's actually in a sweatshirt. There's like a little robot in a sweatshirt, and it was like, and we had D-do-boo, but the problem is D-do-boo wasn't actually correct, it's D-dick, it just doesn't sound good. So, DDX-boo is like, it just doesn't sound good. D-do-boo-boo sounds
It was
like,
so confusing because I asked someone how it's supposed to derive this the exponent, and they're just like, boo limbu, and I'm like,
what? So it sounded more fun when it was D-do-boo-boo, but then, now it's just, okay, the derivative of boo is boo. Limb, right? So, derivative of b to the u is b to the u times ln of b times u prime. I know it's silly, but guys, okay, you can think of the whole, like, hey, exponentials, derivative of e to the x is e to the x, derivative of b to the x is b to the x times ln of b. But a lot of people forget this rule. A lot. Even though they are so similar, they remember this one, but they forget this one. So if it helps, it might help just a little bit, yeah. If people start submitting ideas, there are some people in period 6. I think 2 people already have ideas, but they haven't printed them off and given them to me yet. BC is starting to submit ideas. We have 1, but the math is actually not so hot on that one, so we wouldn't really keep it. So they are getting inspired. We do have a test early next week. Let's say by Friday, all submissions in. I'll give you guys extra credit for any, not for any submissions, for 1 submission, but you can put as many ideas on that 1 submission, but you only get 1 extra credit on that. But by next Friday, print it out, turned in to the back track. Sound good?
cool.
Okay, then we'll just go ahead and put all the design ideas that are possible to be approved, because some of them will not possibly be approved. I'll put them on poster board, you guys can vote, and then we'll go ahead and give it to the design guy. Alright, let's take some derivatives. So wait, when are the designs due? Next Friday.
This Friday.
This Friday.
This Friday, tomorrow? No.
Be ready.
Alright, just a quick heads up, when you go looking for math jokes, because most of you go looking for like calculus
No
problems or meanings or
inappropriate
jokes.
ones.
Nerds can be really inappropriate just like anyone else. So just realize that I do not endorse or approve all of the nerdy jokes that you will see online, and please think of what is possible to be approved or not. Or narrowing down something that you would like to submit as an idea. If you want to draw something, you may just make sure it's fairly professional so that we can tell whether you're
It's just
What?
Don't come near me or my son. I don't get that one.
Yeah.
Oh, it was all from some meme or something.
Yeah, no, it's
What is it?
No, it's just that's
Something about like, I don't know, is that, did you guys ever hear the whole like, or my son or my son's son?
I think
Yeah.
it's like
Whatever that is, it's based off
like
of
you take
that.
something and you make it smaller, so like kind of like the Matryoshka dolls, where like that idea like.
Yeah, but it's not the chain rule, they did different
They- they
derivatives.
just
So it's like my son is the first derivative, my son's son is the second derivative, my son's son is the third derivative. That's it. Okay, how to do the derivative of 2 to the x?
2x times ln of 2.
Yeah, 6x is
ln of who?
2.
2. B is 2. Now what do you think? Someone who sees this for the first time maybe hasn't used this rule or sees it in a few months and hasn't thought about the rule in a long time. What do you think they might naturally do that is very, 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 very wrong? They would bring down the x.
Oh, big no-no.
Big
X
no-no.
minus 1.
What about
Because the power rule works when you have a variable to a constant. Then I bring down the n and subtract 1. But what's going on here? Variable to a constant?
No,
Backwards. Constant to a variable. There is a special rule. You cannot use power rule. Illegal. So we do boo and boo. Which? Boo?
Yay!
B to the x is B to the x?
Oh, that's boom.
Or B to the u?
Oh, it is. What is
Yeah.
that?
B to the u.
Oh, yeah, because.
B to the u, boo. Limb, which would be ln of b, which is the 2. Times u prime, and u prime, well, u is just x, so it's just 4.
Alright.
Because you derive u.
If you want to think about it, b is 2, and u is x. So b to the u, ln of b times u prime, but u prime is just 1. Now what's going on in b?
E to the x squared times 2.
Yeah, but let's try to use the b to the u, just because e is a b technically. So b is equal to e, u is equal to x squared, u prime is equal to 2x. So dy dx would equal boo, e to the u, limb, ln of the base,
So 1.
boo, u prime. Does boo limb boo even work for e to the u?
Well, yeah, but
Because ln of e is just
1.
1, which is why we have a special rule for e to the u, which is just e to the u times u prime. But, I don't know, maybe it's easier to write the 2x before e to the u.
Yeah.
See, my boy.
Austin!
He's alive!
I'm alive.
Yes,
He got to a pretty good time. I don't think he stopped for breakfast.
Did you stop for breakfast and there was chocolate?
Oh, no.
Look at him. He just powered through.
You good?
Alright. So letter C. Ooh, letter C.
No,
Bullshit! Just saying.
We could.
Thanks, Sean.
We could do quotient. Does anybody have any other ideas?
Make it a negative power.
We didn't get it.
Oh, you didn't get it yet? Sorry.
Do we put
I don't know, because I did the question.
I would do ln. That's going to make it
And then we
messier.
can pull things out after the question. Like,
I'm just gonna multiply by
Wait, is
e
that
to the
square?
negative 2.
Question. Can you understand my rewrite?
Yeah,
It's the same thing.
Same base. I can subtract the powers. How does that make everything a whole lot easier?
Well, now
It's
you just
e
have
to
go,
the u.
What's that white one?
Could quotient rule have worked? Yes, but we would have to do a lot of simplifying.
That's so much easier.
Right?
Same base rule, right?
Yeah. Yeah.
Wait, it's
Same bases, I can subtract the powers.
Why
Like-
Oh, David.
If I was to do something like x to the 5 over x squared, isn't that x to the cube?
Yeah.
So x to the a over x to the b,
Oh.
I don't know my letters, it's okay, is equal to x to the
A minus
a
B.
minus b. That's
Yeah.
all we used. Nicely done.
No, it's too complicated.
Now it's time to take a derivative. All right, you go do your quotient rule. Have fun. Derivative. How do I do the derivative of e to the u? Remember, we don't have to use the long rule. We did on this one just to show it worked. But on this one, I don't need the long rule. All I need is e to the u times u prime, right? You need to write it out. You can write it out. It's going to end up being, well, we didn't do u prime yet.
So if we're going to play everything,
Yeah. Well,
I mean, it's just extra to do for like this.
What were you saying?
That was just okay, basically saying that Boo always
Yeah, Booloo always works, as does log base b of u is 1 over u ln of b times u prime. That one always works also. Just the ln of b's will always
Yeah.
So then if we wanted to guess, we could do the 2.
Boo. Kyle Boo.
Kyle Boo. I love that guy.
Man, Kyle is a champ.
Kyle Bobby. That's right.
Oh, Bobby is a Booloo.
He's a boo-boo.
Austin, what they're saying is that I was telling them there's a way of remembering this rule.
Oh.
And the derivative of boo, which is b to the u, which is kind of like b to the x, is boo, limb, boo. So the way of remembering it. Oh, wait, sorry. Oops, there you go.
Oh, okay, cool.
Got it? B to the u times u prime? Okay, a couple more seconds. Pass out.
From Mexico.
Pass it back to Crystal. Or Zach. And pass back to Crystal. Okay.
Where's mine?
Too bad, David, you're not special.
Okay. Question. What rule? What rule would you need for this one?
Wait, no. So we need chain, but do we also need
What's the big picture? Product?
The LNX.
I want some power, but I don't see how
You could just-
power.
Raise everything. Oh.
Power, you would need variables, check, to a constant, not check. Limbu, you would need a constant, not check, to a variable. Check.
Oh, Misty. Wait, no, never mind. I was gonna say that we could put the
It
x
is,
cubed
it
minus
could be,
2x
if
into.
this has x's,
Oh, you didn't
I was
put
gonna-
that
I
one?
was
this
saying
is not a b.
Put it into it, but we can't.
Yeah, do you
That's
have
not-
like a
that's
big
not-
chain rule?
What they said?
L on each side or this.
Yeah.
Something
Yeah,
different.
and then get rid of
Why L on both sides?
Well, you can get rid of
The
the half of
only
that.
way
To bring.
to break down the power, the only way to break out of power. Whoo! The only way to break out of power. Now, sadly, once again, we're kind of using that new technique that we're not going to really learn until section 2.5. But I just wanted to show you this one was not able to use either of those rules. And why? Because it was an x to an x. It was an f to a g. It was a u to a v. It didn't fit u to the n or b to the u. It's a u to the v. Can't use the power and can't use the b to the x. At this point, we would need to use our thing called implicit. We would need to take d dx at both sides. And then, now that ln broke out the power, now what's the big rule?
Oh, wait, no.
Chain's involved, so that's not the big rule. Product rule is the big rule. Now, guys, I'm just going to do a dot, 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 because we technically haven't learned implicit. So even though you did just see me a second ago say that this was 1 over y times dy dx, which is totally true, and you would be able to do a product rule over here, we're going to go ahead and just stop and say, ooh, but we technically are kind of looking at the future, looking at problems that we don't really need to master quite yet. But once again, when you see a function to a function, an f to a g, a u to a v, does the power rule or the exponential rule, either one of them, are they legal to apply? No. They're not legal to apply. Alright, we'll come back to that after the section.
What's what we just learned?
Wait a minute, isn't that what I just did?
Yeah.
Okay, forget this slide. Get rid of him. We don't need him. So I already did, well, I already did the whole block. Is there room to leave?
In general,
Yeah. Skip this one.
Twice now. Wait, we ended on the y equals x.
We're done. Ta-da! Yeah, you guys are right. We did this one up here. We did have this one just for a little bit, but remember how I was like, ooh, we need to learn some extra stuff? You can put a ... on this example if you wrote this one down. You can put a ... on him also. Because once we learn implicit after the test, we can come back and look at these examples. Alright, kiddos. I do want to grade our homework, but first, we have a test coming. Workspace. If you want to get your spiral, you can.
But we're basically done with class.
But I'm checking homework. We're doing everything in spiral from here on out.
Oh, I must check it at home.
Oh my goodness.
Okay. I'll just do 2 homework problems.
You guys are allowed to work in groups. On these 3 questions, 2 of them are multiple choice. The last one is long answer. It's just a short answer, like show your work on A, B, C, and D. You can call this 2.4. 2.4 AP practice or 2.4 exam prep.
Oh.
It looks scary.
Okay, so you gotta use the rhythm.
But can I just give everyone a quick hint real quick?
Yeah.
I think Nathan's already saying it.
You just plug in 3D.
Your goal is not to figure out this table. It's just been given to you.
Yeah.
Ignore him. He's how you plug in stuff later. What's your goal to figure out? You have to use your rules to figure out who his derivative would be, and then plug in whatever, then plug in 3, then go to your table and say, all right. Okay, go. A little different.
So 2 to the 5, what's that? So x to the times 5.
I'm going to pause the video while you guys work. The even's ready. I suppose you can be looking over this and trying to see what went wrong. But if you do have the evens ready, here we go. 142, 62. 152, 166.
I only have 12 times 3 for some.
Do you guys see how they used b to the u times ln of b times u?
Yeah. Can I take a look at the board?
Hold on, I need the microphone because I'm recording.
Wait, what's it?
It's behind the board.
What's it negative?
U derivative of negative x is negative 1. Yeah. U prime. Number 162 had to bring down the 3, make it a 2, then U prime is G prime, then plugging into a table. So if you guys figured out 191, it'll help you on 162 if you hadn't gotten there last night. Number 166, you were supposed to find the velocity, I think, which means you had to take the first derivative, plug in. This looks like, pi over 8 is not unit circle, guys, so you would have been able to use your calculator.
But no,
when you
times by 12, it's 0.
Oh, so it ends up being unit circle? Never mind. Let's see, and then number 184, I think that was the last one.
Yeah.
I think it gave you a rule in number 184. We're actually going to add that rule to one of our forever cards tomorrow, but we won't worry about it today. Alright, kiddos, you've checked the evens. Tomorrow is a work day in lots of ways.